With the development of quantum mechanics, the role of the observer became an even more central part of the physical theory, an essential component in defining an event. The mind of the observer emerged as a necessary element in the structure of the theory. Page 38. Werner Heisenberg, one of the founders of the New Physics, became deeply involved in the issues of philosophy and humanism. In his text, The Philosophical Problems of Quantum Physics, he wrote of physicists having to renounce thoughts of an objective timescale common to all observers, and of events in time and space that are independent of our own ability to observe them. Heisenberg stressed that the laws of nature no longer dealt with elementary particles, but with our knowledge of these particles, that is, with the contents of our minds. The view of a large number of contemporary physicists and scientists are summed up in the essay Remarks on the Mind-Body Question, written by Nobel laureate Eugene Wigner. Wigner begins by pointing out that most physical scientists have returned to the recognition that thought, meaning the mind, is primary. He goes on to state it was not possible to formulate the laws of quantum mechanics in a fully consistent way without reference to the consciousness. And he concludes by noting how remarkable it is that the scientific study of the world led to the content of consciousness as an ultimate reality. A further development in yet another field of physics reinforces Wigner's viewpoint. The introduction of information theory and its application to thermodynamics has led to the conclusion that entropy, this is a basic concept of that science, is a measure of the observer's ignorance of the atomic details of the system. When we measure the pressure, the volume, the temperature of an object, we have a residual lack of knowledge of the exact position and velocity of the component atoms and molecules. The numerical value of the amount of information we are missing is proportional to the entropy. In earlier thermodynamics, entropy had represented, in an engineering sense, the energy of the system unavailable to perform external work. In our modern view, the human mind enters once again, and entropy relates not just to the state of the system, but to our knowledge of that state. Now granted, The Mind's Eye is the 1982 text. Let me update you on this idea of entropy. I have none other than Murray Gell-Mann, The Quark and the Jaguar, Adventures in the Simple and the Complex. Really remarkable book. This is W.H. Freeman and Company. This was published in 1994. Entropy is Ignorance, page 219. Murray Gell-Mann, one of the founders of quarks. In fact, he's the one that named it quark, the subatomic particle, the quark. Entropy and information are very closely related. In fact, entropy can be regarded as a measure of ignorance. There you have it. And he goes on to describe more and more, but I just wanted to let you know, in 1994, Murray Gell-Mann in The Quark and the Jaguar said basically the same thing as Harold J. Morowitz. Well, page 39. First, the human mind, including consciousness and reflective thought, can be explained by activities of the central nervous system, which in turn can be reduced to the biological structure and function of that physiological system. Second, biological phenomena at all levels can be totally understood in terms of atomic physics, that is, through the action and the interaction of the component atoms of carbon, nitrogen, oxygen, and so forth. Third and last, atomic physics, which is now understood most fully by means of quantum mechanics, must be formulated with the mind as a primitive component of the system. We have thus, in separate steps, gone around an epistemological circle, from the mind back to the mind. Finally, on page 42, to underrate the significance of the appearance and character of reflective thought is a high price to pay in order to honor the liberation of science from theology by our reductionist predecessors several generations back. The human psyche is part of the observed data of science. We can retain it and still be good empirical biologists and psychologists. That's something a lot of physicists just don't accept anymore, but be that as it may, that's one of Horowitz's ideas by Douglas Hofstadter. Now what I want to do is explore, I'm trying to debate here whether I want to discuss Evan Harris Walker. Well, let me go to Manus Kaffatos and Robert Nadeau, The Conscious Universe, Part and Whole in Modern Physical Theory. This is by Springer Verlag. This was published in 1990. A most astonishing little text, very powerful, and I want to give you the basic rundown of chapter 9, the grand finale of what they have concluded based on their very serious analysis scientifically of quantum physics. On page 173, nature in classical physics was viewed as forces acting between mass points in the abstract background of space and time. Thus the universe became a vast machine, in which collections of mass points interacted with one another in terms of external forces dependent only upon the masses and the effective dynamics between them. The knowing self was separate, discrete, atomized, and achieved its knowledge of physical reality from the outside of physical systems without disturbing the system under study. For instance, a man looked through the telescope to observe the moon, something to that effect. Well, classical physics not only fails to demand the mental, it fails to even provide a rational place for the mental. This is classical Newtonian physics. This was the element the quantum physics brought back in. In addition to providing a view of human beings as mere cogs in a giant machine, linking to other parts of the machine in only the most mundane material terms, classical physics also effectively isolated the individual self from any creative aspect of nature. In the classical picture, all the creativity associated with the cosmos was exhausted in the first instant of creation, and what transpires thereafter is utterly preordained. All of modern physics contribute to a view of the universe as an unbroken and undissectable dynamic whole. This is our new situation because of the quantum. Particles cannot be viewed as separate and discrete. Page 174. Each atom turns out to be nothing but the potentialities in the behavior pattern of others. What we find in our new view now are not elementary space-time realities, but rather a web of relationships in which no part can stand alone. Every part derives its meaning and existence only from its place within the whole.